Hi folks, this is Karim Raouf for IT Visualizer channel. We will continue our Lab Matrix Labs, the video number 101. We have been discussing in the previous video the following. We are still working with the topic of troubleshooting and repairing Windows operating system using SFC and DISM commandlets. We have seen that we have used AI tools to generate useful scenarios and useful explanations concerning this topic by feeding up all of these AI tools with the PDF of Mr. Lo Vanderpool from Tech Savvy production channel. We have seen that the AI tools had begun generating useful hands-on exercises, useful explanations. We are representing a junior IT, so is simplifying the explanations as easy as possible. So we will continue with the AI tools, and now I am asking him to explain the same topic but using a different method, not through hands-on exercises or through simple explanation, but with another way. We will see the prompt that I have provided to the AI tools, and I deliberately will read the prompt so that you all can benefit from it. So here I'm asking him to imagine that you are a seasoned senior IT working with me, a junior IT administrator, to deepen my understanding how to repair Windows 11 using SFC and DISM. Based on the PDF of Mr. Lovantelpour, video notes how to repair Windows 11 using SFC and DISM.pdf, we will explore various scenarios and examples related to that. Phase 1 of the dialogue between the senior IT and the junior IT, concept explanation and visualization. As a junior admin, will then be asked to explain the concept in my own words. The first phase of the discussion is the concept explanation and visualization. I will be asked a junior admin to explain the concept in my own words, provide a real-world example or scenario demonstrating its use. Number 3, illustrate the concept visually if possible, such as drawing a diagram or outlining a step-by-step process. After I provide my explanation, you as a junior or you as the AI instructor will evaluate my understanding, I identify any gaps or inaccuracies, provide further clarifications and detailed explanations, offer alternative examples or analogies to enhance comprehension. Number 4, suggest practical ways to apply the concept in our organization's Active Directory environment. I'm focusing on Active Directory environments, by the way. Phase 2, practical application and case study analysis. Iterative approach. For each subsequent phase, present me with a practical scenario or case study related to the concept. I need to apply the learned concept to analyze the scenario. 2, purpose a solution or design based on my understanding. Number 3, justify my approach. You will then provide feedback on my proposed solution, highlight strengths and weakness, discuss alternative approaches and best practices. 3, walk me through a comprehensive analysis of the scenario, reinforcing the concept's application. Through the exercise, focus on developing my ability to articulate and explain complex technical concepts, connecting theoretical knowledge to practical applications, encouraging visual and creative thinking to enhance understanding. By the end of this exercise, I should be able to confidently explain the topic and apply them effectively in our organization. Simulate my answers as a junior IT. Here I am adding another line here. This is for me. Simulate my answer as a junior IT and the reply of the senior IT. Simulate them both. I will not put any answer. If you need this conversation to be interactive, then do not put the last line. If you put the prompt until this part, then you will be asked as the provider of the input to explain the concept. Then the AI will evaluate the answer and explain it further, and this is how the conversation goes. If you need to have a seamless or a continuous dialogue, then you need to tell him simulate my answer as a junior IT and the reply of the senior IT. So the AI will ask the question and answer himself. This will give us more rich answer, because the AI will have two roles. He will play the role of a junior IT and a senior IT. He will first explain it in a simple way and then in a technical way. Okay, continue this conversation as far as the situation needs. Okay, so let's see what will be the answer of Gemini concerning this concept. Let's try to see what will be the answer here. Okay, again, sorry. Okay, let me try to uh, just do like that. And uh, here, for example, this is the first answer. We need to uh, see what is it exactly.
All right, let's dive into the world of SFC and DISM. I'm your seasoned senior IT guide, and we'll work together to make sure you have a solid grasp of these tools. Remember, we're focusing on how these concepts apply to repairing Windows 11, as outlined in the video notes how to repair Windows 11 using SFC and DSM.pdf. Phase 1. Concept explanation and visualization. Let's start with the core concept, repairing Windows 11 using SFC and DSM. Your task, Junior IT. Explain the concept in your own words. What are SFC and DSM, and how do they work together to repair Windows 11? Provide a real-world example or scenario where you would use these tools. Illustrate the concept visually. This could be a diagram showing the relationship between SFC, DSM, the component store, and Windows Update, or a flowchart outlining the steps involved in a typical repair process. Take your time, and I'll be here to review your understanding. Don't hesitate to refer back to the PDF notes. Show me what you've got. Junior IT response simulation. Okay, so here's my understanding of SFC and DSM for Windows 11 repair. Concept explanation. SFC, or System File Checker, is like a built-in tool that checks if Windows system files are okay. If it finds any that are corrupted or missing, it tries to replace them with good copies. DISM, which stands for Deployment Image Servicing and Management, is a bit more advanced. It's used to fix problems with the Windows image itself, which is what SFC uses as a source for those good copies. So basically, SFC tries to fix files, and if it can't, DISM steps in to repair the source that SFC relies on. They work together to fix Windows. Real-world example. Let's say one of our office computers is acting weird after an update. Programs are crashing, and maybe there's even a blue screen error. I would first try running SFC to see if it can fix any corrupted system files. If SFC can't fix everything, I would then use DISM to repair the Windows image, hopefully solving the underlying issue. Visual illustration. Plus, 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 plus Windows 11 OS. SFC scans. Repairs potentially system files corrupted plus, 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 plus caret plus, 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 V, plus, plus, plus component store, DISM, Windows Update, WinSXS, repairs, or local source, plus, 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 plus. Use code with caution. Senior IT, AI instructor, response. Not bad for a start. You've grasped the basic relationship between SFC and DISM, and your example scenario is relevant. However, there are some nuances we need to clarify. Evaluation of junior IT understanding. Strengths. You correctly identified SFC as the first line of defense for system file corruption. You understand that DISM is used when SFC fails and that it deals with the underlying Windows image. Your real-world example is appropriate. The diagram is a good starting point, showing the basic flow. Gaps and inaccuracies. You mentioned that DISM steps in to repair the source that SFC relies on. While conceptually correct, it's more accurate to say DISM repairs the component store, which is the repository of system files that SFC uses. The component store is not just a source, but a complex database of file versions. Your diagram doesn't quite capture the fact that DISM can use either Windows Update or a local source, like an ISO, for repair files. You haven't touched upon the different DSM commands, such as /check-health, /scan-health, and /restore-health. You did not mention the DISM log file and how it may be used to troubleshoot errors. You did not mention the need for elevated permissions when running SFC and DISM. Further clarification and detailed explanations. Let's refine your understanding. SFC's role. SFC is indeed the initial diagnostic and repair tool. It's crucial to remember that it compares the system files against a cache copy in the component store. If the cache copy is also corrupted, SFC will likely fail. DISM's role. DISM is more than just a repair tool for the source. It's a powerful command line utility that can check the health of the component store, /check-health, quick check, /scan-health, more thorough scan. Repair the component store, /restore-health, uses Windows Update or a specified source. Perform other image management tasks, adding /removing drivers, packages, enabling /disabling features, etc. The component store, WinSXS, this directory is vital. It's not just a simple storage location. It contains multiple versions of system files, allowing for rollbacks and system repairs. Windows uses hard links to manage these files efficiently, which means the actual size of WinSXS is often smaller than it appears. Local source versus Windows Update. DSM can be instructed to use a local source, such as a mounted Windows 11 ISO, for repair files. This is useful when the computer has no internet access. You want to use a specific, trusted source. You need to repair an offline image, e.g., a mounted WIM file. Elevated permissions. Emphasize to always run Command Prompt or PowerShell as an administrator when using SFC and DISM. Alternative analogy. Think of it like this. Windows 11 OS, the building with many rooms, system files. SFC, a building inspector who checks each room for damage and has a set of blueprints, cache copies from the component store to make minor repairs. Component store, WinSXS, a large warehouse storing various sets of original blueprints and building materials. DISM, a specialized repair crew that can restore the warehouse itself if it's damaged, using either new supplies delivered from a central depot, Windows Update, or a local supply truck, local ISO. Practical application in our organization's environment. In our Active Directory environment, you might encounter scenarios like post-update issues. After pushing Windows updates through WSUS, some machines exhibit problems. You'd use SFC and DISM to repair them. Group policy for scheduled maintenance. You could create a group policy object, GPO, to schedule a monthly task that runs DSM/scan-health to proactively monitor the health of the component store on all domain-joined Windows 11 computers. If corruption is detected on any computer, you may run DSM/online/cleanupimage/restore-health to repair the component store. Driver issues. If a new driver causes widespread issues, you can use DISM to remove the problematic driver from the affected machines and even from a custom Windows image used for deployment. Revised visual illustration. Plus Windows 11 OS, SFC scans, repairs potentially /scan now system files corrupted. If possible, caret checks against component store, DISM, Windows Update, WinSXS, /check-health, online file, /scan-health source repository, /restore-health caret. Or uses files from v++, local source e.g. ISO Use code with caution. Phase 2. Practical application and case study analysis. Now, let's move on to some practical scenarios. Scenario 1. The case of the missing DLL. Problem. A user, Bob, reports that a specific application, Axe, crashes on startup with an error message mentioning a missing DLL file, crucial.dll. This application is essential for his daily work. Your task, Junior IT. Analyze the scenario. What could be the cause of the missing DLL? How can SFC and or DISM help? Propose a solution. Outline the steps you would take to resolve the issue. Justify your approach. Explain why you chose those steps. Take your time, and I'll be here to provide feedback. Remember to think about the steps involved and how you would verify the outcome.
Okay, so let's see the answer of the junior IT. This is the simulated answer. Now we can continue with the same answer and see. Here you go. Okay, let's go further. Okay, let's go to this one.
Phase 3, Scenario 2, the unbootable system. Problem. Okay, here's my take on Scenario 1 as the junior IT administrator. Scenario 1, the case of the missing DLL. 1. Analysis of the scenario. Possible cause. The crucial.dll file, which Axe needs, is probably either corrupted or got accidentally deleted. This could have happened because of a bad update, maybe some other software messing with it, or even just a random glitch. Since it's a system file, Windows should normally protect it, but things can still go wrong. How SFC/DISM can help? SFC is the first tool I'd use. It's designed to find and fix missing or corrupted system files. If crucial.dll is a standard Windows file, SFC might be able to replace it from its cache. If SFC fails, it could be because the component store is damaged, and that's where DISM would come in. DISM can fix the component store so SFC can do its job properly, or if the DLL isn't a core part of Windows, I might have to reinstall the app or find the DLL online. 2. Propose solution. Run SFC. I'll open command prompt as an administrator and run SFC/scan now. Check the results. I'll see if SFC finds any problems and if it can fix them. If SFC fails, I'll use DISM. I'll start with DISM/online/cleanupimage/check health to see if the component store is damaged. If the component store is damaged, I'll run DISM/online/cleanupimage/restore health to fix it, assuming the computer is connected to the internet. Rerun SFC. After DISM, I'll run SFC/scan now again. If the problem persists, I'll check if crucial.dll is part of Axe. If so, I might try to reinstall Axe. 3. Justification. I'm starting with SFC because it's the simplest and fastest way to fix common system file issues. If SFC fails, it's logical to check the component store with DISMs/check health because a corrupted component store can prevent SFC from working. Using /restore health is the next step to try and repair the component store if it's damaged, using the internet to get the files needed. Reinstalling Axe is a last resort for this specific application if all else fails, since the problem appears to be with the application. I think this covers all the bases. What do you think? Simulate senior IT answer. All right, that's a good attempt. You've laid out a logical troubleshooting process, starting with the basics and escalating as needed. Your reasoning is sound, and you've demonstrated a decent understanding of the roles of SFC and DISM. Feedback on your proposed solution. Strengths. Correct order of operations. You correctly prioritized SFC as the initial step and recognized that DISM is needed when SFC fails. Logical progression. Your steps follow a reasonable troubleshooting flow, moving from simple checks to more complex repairs. Understanding of DISM commands. You've used the correct DISM commands /check health, /restore health for checking and repairing the component store. Justification. Your justification for each step is valid and demonstrates a basic understanding of the tools. Weaknesses and areas for improvement. Missing verification steps. While you mentioned checking the results, you didn't specify how you would verify if the issue was resolved after each step. For example, after running SFC, you should try launching Axe to see if the error is gone. Similarly, after running DISM, you should rerun SFC and then test the application. Lack of detail on DISM source. You mentioned using /restore health, but you didn't elaborate on the source. In a corporate environment, you might need to use a specific source, such as a network share with approved Windows images. You also should specify the /limit access tag, so it does not attempt to contact a WSUS. Limited troubleshooting scope. You jump to reinstalling Axe a bit too quickly. There are other things to consider before that. Event Viewer. Checking the application and system logs in Event Viewer might provide more specific error messages or clues about the cause of the problem. Dependency Walker. This tool can help determine if Axe is missing other dependencies besides crucial.dll. Check if file is present. You may want to check to see if the file is present on the system by using File Explorer or the command prompt. Missing security considerations. You didn't mention checking if the user has the necessary permissions to run these commands. Local administrator. Alternative approaches and best practices. More thorough initial assessment. Before running any commands, gather as much information as possible. Exact error message. Get the full text of the error message. It might provide more clues. Recent changes. Ask the user if any software or updates were installed recently. Event Viewer. Look for related errors or warnings. Specifying DISM source. If the computer has internet access, using Windows Update is fine. However, in a managed environment, consider using a local or network-based source for DISM. This ensures consistency and control over the repair files. You can use the /source parameter with DISM, /online /cleanup image /restore health /source. Vim, e. /sources /install.vim. 6/limit access. Replace E with your mounted ISO drive letter. Offline repair. If necessary, if the computer cannot boot into Windows, you can perform an offline repair using SFC from the Windows Recovery Environment, WinRE, as outlined in the PDF. Comprehensive analysis of the scenario. Here's how I would approach the scenario, building on your solution. Gather information. Get the exact error message from the user. Ask the user about recent software installations or updates. Check the application and system logs in Event Viewer for related events. Verify user permissions. Ensure you are logged in with an account that has local administrator privileges. Run SFC. Open an elevated command prompt. Run SFC/scan now. Verification. After SFC completes, check the output. If it reports successful repairs, try launching Axe. Run DISM if SFC fails. Open an elevated command prompt. Run DISM/online /cleanup image /check health. Verification. Check the output. If it reports that the component store is reparable, proceed to the next step. If it is not reparable, perform an in-place upgrade or a Windows reset. If reparable, run DISM/online /cleanup image /restore health /limit access. If there is no internet access or you need to use a local source, use DISM/online /cleanup image /restore health /source. Vim path_install .vim index number /limit access. Verification. Check the output for success. Rerun DISM/online /cleanup image /check health to confirm the component store is healthy. Rerun SFC. After DISM completes, run SFC/scan now again. Verification. Check the output. If it reports successful repairs, try launching Axe. Further troubleshooting if the issue persists. Dependency Walker. Use a tool like Dependency Walker to check if Axe is missing other dependencies. Check for file presence. Use File Explorer or the command prompt to see if crucial.dll is present in the expected location for Axe. System Restore. If the problem started recently, consider using System Restore to revert to a previous state. Reinstall acts. If all else fails, try reinstalling the application as you suggested. Document everything. Make sure to document each step you took, the results, and any error messages encountered. Phase 3, Scenario 2, the unbootable system. Problem: a critical server, DC02, in your organization's Active Directory environment experienced a power outage and now fails to boot. You suspect that system files may have been corrupted. You have physical access to the server and a bootable USB with the Windows 11 installation media. Also, the system drive is encrypted with BitLocker. You will need the recovery key. Your task, Junior IT. Analyze the scenario. What are the potential causes of the boot failure? How can you use SFC and or DISM in this situation? Propose a solution. Outline the steps you would take to resolve the issue, considering the offline nature of the problem. Justify your approach. Explain why you chose those steps. The simulation will continue in the next turn with your response as the Junior IT. Run control. Run settings. Get code.
So, very, very good explanation, very, very good logical thinking. Actually, it provides us with a professional way to handle corrupted file systems. We see that the junior IT is his answer is very, very simple and straightforward, but it lacks the professionality and missing some details. And then the senior IT is giving more professional and detailed answer. And actually, this was not mentioned in the hands-on exercises or in the simple explanation in the previous answers of Gemini. So I think we are getting the best of these AI tools. Let's tell him to simulate my answer as junior IT, and let's see how he will answer this one. So we can go and see the scenario before, or he said that we have DC02 experience a power outage. This happens often, and then you cannot boot. So one of the boot files, maybe it is corrupted. We have a USB that contains Windows 11 installation media. Actually, this C02, this refers to maybe a domain controller. So most domain controllers doesn't have Windows 11. So this can be Windows Server. This will be more logic. So, and he is giving us another scenario that the system driver is encrypted. So any repairing to the files, I think, will be difficult because the system files are encrypted. So let's see this scenario. It seems interesting. Let's see how he will uh, go with this scenario. Okay, here is my analysis and proposed solution for scenario 2, the unbootable server. Let's read the answer. Okay, let me first read it, or read the answer, and then ask him to simulate the answer of the junior IT. Sometimes, even though I asked him in the prompt to go further with the discussion, but sometimes I need to tell him to continue the conversation. Okay, let's read out loud from here.
Okay, here's my analysis and proposed solution for Scenario 2, the unbootable server. Scenario 2, the unbootable system. 1. Analysis of the scenario. Potential causes. The sudden power outage could have corrupted system files crucial for booting. Since the server won't start, it's likely that core operating system files are affected. It's also possible there's damage to the boot configuration. Because the system drive is encrypted with BitLocker, I will need to make sure I have the recovery key. How SFC/DISM can help. Since the system is offline, I can't use the regular online versions of SFC or DISM. But I can use them from the Windows recovery environment, WinRE, that I can access from the installation media. SFC can scan the offline system files and try to repair them. DISM might be needed if the component store is also damaged, but I'm hoping SFC will be enough since it's a boot issue. 2. Proposed solution. Boot from USB. I'll boot the server using the Windows 11 installation USB drive. Access WinRE. I'll choose the Repair Your Computer option and then go to Troubleshoot Advanced Options command prompt. Unlock BitLocker drive. I will find the BitLocker recovery key for the system drive to unlock it from WinRE. Identify drive letters. I'll use diskpart and then list volume in the command prompt to figure out which drive letter is for the Windows partition and which is for the system reserve partition if present. Run SFC offline. I'll use the /offbooter and /offwinder parameters with SFC to specify the boot directory and Windows directory. It should look something like this. SFC/scannow /offbooter equals C. /offwinder laughing face : /Windows, assuming C is the system reserve partition and D is the Windows partition. Check SFC results. I'll wait for SFC to finish and check the output to see if it found and repaired any errors. Reboot. If SFC was successful, I'll try rebooting the server normally. 3. Justification. Booting from the USB is necessary because the system can't start on its own. WinRE provides the tools I need for offline repair. Using diskpart is essential to identify the correct drive letters in the recovery environment because they might be different from what they are when Windows is running. The /offbooter and /offwinder parameters are crucial for telling SFC where to find the offline system files. Rebooting after SFC is the logical next step to see if the repairs worked. If SFC fails, then I will have to perform an offline repair using DISM. I think this is the right approach for an unbootable system. What are your thoughts?
So I have here a little bit of a concern how we can unlock BitLocker driver. Okay, let's see how we can ask, for example, ChatGPT to answer this question. How to do that from WinRE boot using WinRE and from CMD. So here we can see that. Let's see how he will do that. Okay, so here we can see that this is the answer how we can to unlock a BitLocker encrypted system drive from Windows recovery environment using the command prompt. Follow this one. Restart, then go to the appropriate keys, F8 or F12 or Del to access the boot menu or advanced options to let him boot from the USB. Then we go troubleshoot advanced options command prompt from the Windows bootable flash drive, bootable DVD or bootable operating system flash drive. Then we need to find the key. The recovery key is 48-digit number and can be usually be found in your Microsoft account. Print or saved USB. This is one that you need to have printed and saved in a safe or something, or in the Active Directory. You can get it from the Active Directory because it will be saved to the computer object in your Active Directory. Then we need in the command prompt to type the following command to identify the encrypted drive. This manage BDE status Let me see if this can work from CMD to make sure that I don't have, actually I don't have any encrypted drivers. So now we can run as administrator, and then we can type this one. Here we can see that there is the status. This is fully decrypted, so we don't have anything. We have protection off, lock status unlocked. So we have this will give us the situation of the drivers, and then he will the next prompt is to the next thing is unlock and then recovery password. Then you put the key, replace X with the letter drive of the encrypted drive. So for example, we need to unlock the C partition or the system partition that contains our WinSSX folder or our operating system files. Okay, and then put the digit, and then it will be disabled. We can then work with SFC to repair it, or DISM. If you want to disable BitLocker temporary to access the system, so you need to put first, let me see what this point is saying here. You need to unlock the drive using the recovery key. If you want to disable BitLocker encryption temporary, the access system use the following commandlet. So you need to put the encryption key, then disable BitLocker temporarily. If you want to remove BitLocker, this is optional. Okay, so access the system. So what after I finish, I need maybe to tell him enable after that. So we need to disable and then enable, maybe minus BD protectors, then enable. Okay, so this can be the situation. Let me tell him what I need to enable BitLocker again after finishing repair of file system. So we tell him enable or disable, and then we get the status. So this is a good thing. Okay, optional manage BitLocker. So he's giving us also some steps to get the BitLocker key. Anyway, we have already it saved in the Active Directory, or we can get it from the system itself. Control panel, system and security, BitLocker and driver encryption, backup. If you made changes, you can tell him BitLocker driver encryption, backup your recovery key from the control panel. Control panel, BitLocker driver encryption, backup your recovery key. Okay, so a good thing to know how we can do these steps. Okay, just a moment, guys. So let's continue, guys. Here we will see the answer of the senior IT. We have seen how we can unlock BitLocker while we are in the Windows recovery environment. So let's see how this scenario will work. We have a situation that we cannot boot our DC02 server. There is a problem with the boot files. We are trying to repair it using the offline method through booting the server from a Windows 11 bootable USB flash, and then go to the repair, then troubleshooting, then command prompt, and then try to fix the corrupted boot files using the SFC. But we have a problem that the partition is encrypted with BitLocker, so we need to uncrypt first the partition and then begin fixing the issue. So let's see the answer of the senior IT concerning what was provided by the junior IT. Let's see the answer.
You're on the right track. Your approach is generally correct, and you've identified the key steps for performing an offline repair. You understand the need for WinRE, disk part, and the special SFC parameters. Feedback on your proposed solution. Strengths. Correct use of WinRE. You correctly identified the need to boot into the Windows recovery environment from the installation media. Proper disk part usage. You understand that disk part is essential for identifying the correct drive letters in the offline environment. Correct SFC syntax. You've used the /offbooter and /offwinder parameters correctly. Logical flow. Your steps are in the right order for an offline repair scenario. Weaknesses and areas for improvement. BitLocker. You mentioned that the system is encrypted with BitLocker, but did not specify how you would find the recovery key and use it to unlock the drive. Missing DISM considerations. While you mentioned DISM might be needed, you didn't outline the steps you would take if SFC failed. In a real-world scenario, you should be prepared to use DISM offline as well. Lack of verification details. You mentioned checking SFC results, but didn't detail how you'd verify if the system was fixed beyond just rebooting. No mention of BCD. You did not mention the boot configuration data BCD. The BCD is a firmware-independent database for boot time configuration data. It is possible that the BCD is damaged and needs to be repaired. No mention of startup repair. You did not mention running startup repair. Startup repair is a Windows recovery tool that can fix certain system problems that might prevent Windows from starting. Alternative approaches and best practices. Attempt startup repair first. Before diving into SFC, it's often a good idea to try the startup repair option in WinRE, troubleshoot advanced options startup repair. It can automatically fix common boot problems, including some BCD issues. If this fails, then move on to SFC. Offline DISM. If SFC fails to repair the system files, you should be prepared to run DISM offline. This is similar to the online repair, but you'll need to specify the /image parameter pointing to the offline Windows directory, as well as using the /scratchdir to a folder that is at least 1 GB in size. You may also need to use the /source parameter if you're using a local source for repair files. It would look like DISM /image laughing face : /scratchdr laughing face : /scratch /cleanup image /restore health /source. /sources /install.vim, assuming D is the Windows partition and E is the installation media. You can use DISM /image laughing face : /scratchdr laughing face : /scratch /cleanup image /analyze component store to determine if the component store is corrupt and whether cleanup is recommended. If it is recommended, run DISM /image laughing face : /scratchdr laughing face : /scratch /cleanup image /start component cleanup. Check disk for errors. Since there was a power outage, it's worth running check disk on the system drive to check for and repair file system errors. Use checkdisk D/F, assuming D is the Windows partition, from the WinRE command prompt. Rebuilding the BCD. If the BCD is suspected to be corrupt, you can use the bootrec command in WinRE to repair it. Common commands are bootrec /fixmber, bootrec /fixboot, bootrec /rebuild. Comprehensive analysis of the scenario. Here's a more detailed approach, incorporating the best practices and addressing the weaknesses. Gather information. Confirm the server model and any relevant hardware details. Check if there are any known issues with the server model or recent changes made to it. Note the BitLocker recovery key for the system drive. Boot from USB and access WinRE. Boot the server from the Windows 11 installation USB. Select Repair your computer, troubleshoot, advanced options. Unlock BitLocker drive. You will need to find the recovery key. This might be stored in Active Directory, printed out, or saved to a file. If you cannot find the recovery key, you will not be able to repair the system. Once you have it, you may proceed. Select Command Prompt. At the prompt, type manage-bd, unlock D. Recovery password, recovery key, replacing D with the correct drive letter and recovery key with the BitLocker recovery key. Attempt startup repair. In the Advanced Options menu, select Startup Repair. Verification. Let Startup Repair run and see if it can fix the problem automatically. If it succeeds, reboot and test. Run check disk. If Startup Repair fails, open the command prompt again. Run check disk D/F, replace D, with the correct drive letter. Verification. Check the output for any reported errors and if they were fixed. Run SFC offline. In the command prompt, use diskpart and list volume to confirm the drive letters. Run SFC/scannow/offbooter equals C. //offwinder laughing face : Windows. Adjust drive letters as needed. Verification. Check the SFC output for successful repairs. Run DISM offline if SFC fails. Create a scratch directory. md/d:/scratch. Replace D with the correct drive letter. Run DSM/image laughing face : // scratch dir laughing face : // cleanup image / analyze component store. Replace D with the correct drive letter. Verification. Check the output. If cleanup is recommended, proceed to the next step. Run DSM/image laughing face : / scratch dir laughing face : // scratch cleanup image / start component cleanup. Replace D with the correct drive letter. Run DSM/image laughing face : / scratch dir laughing face : // cleanup image / restore health / source. /sources / install.vim. Replace D with the Windows partition and E with the installation media drive letter. Verification. Check the output for success. Rebuild BCD if necessary. If the system still won't boot, run the following commands in the command prompt. bootrec/fixmber, bootrec/fixboot, bootrec/rebuild. Verification. Each command should report success. Reboot and test. Remove the USB installation media and reboot the server. Verification. If the server boots successfully, log in and check the event viewer for any errors. Monitor the server stability. Document everything. Record all steps, commands used, results, and any errors encountered.
So we can see here this is a very good example, but I think here we need to add health restore. Okay, this is source. Maybe we need to have limit access at the end, /limit access, maybe. But I think here is he's referring to the source file, so he will not repair from the internet. But sometimes he can go to the internet anyway. So I think we can add limit access at the end, or limited access. Anyway, you can see very good example, and seems to be very real. Okay. So we can see a lot of scenarios, and we can see the junior approach, which is a little bit simple and not professional, and the senior approach, which gives more details and more commandlets and more scripts to work with. So let's continue with the fourth scenario, or the third scenario, which is group policy and scripting. And we can see this enhance our experience. We have seen a lot of hands-on exercises, and now we have some enhanced, let's say, hands-on exercise. Okay, let's see and continue with the third scenario, and we will stop at this third scenario after finishing it.
Encountered. Phase 4. Scenario 3. Group policy and scripting. Problem. Your organization wants to implement a proactive maintenance strategy for all Windows 11 computers in the domain to prevent system file corruption issues. Your task, Junior IT. Analyze the scenario. How can you use group policy and scripting to automate SFC and DISM scans on a regular basis? Propose a solution. Design a basic script and outline the group policy settings needed to deploy it. Justify your approach. Explain why you chose these specific methods and settings. We will continue the simulation in the next turn with your response as the Junior IT. 63.4s. Simulate the answer as a Junior IT. Okay, here's my proposed solution for Scenario 3. using group policy and scripting for automated maintenance. Scenario 3. Group policy and scripting. 1. Analysis of the scenario. Goal. We want to proactively check the health of Windows 11 computers in our domain using SFC and DISM, catching and fixing potential issues before they cause major problems. Tools. Group policy is the best way to deploy settings and scripts to multiple domain-joined computers. PowerShell is a good choice for scripting because it can run SFC and DISM commands and handle the logic we need. Frequency. I think running the checks monthly is a good balance. Too often might put unnecessary load on the systems, and too infrequent might miss issues. 2. Proposed solution. A. PowerShell script, monthly maintenance.ps1. Hashtag get the current date and time for the log file, $datetime equals getDate. Format YY1EDHMMSS. Hashtag log file path $log equals C:\Windows\temp\monthly maintenance $$datime log hashtag check component store health $dism check equals DISM /online/ cleanup image /scan health hashtag log the DISM check results add content path $log file value DISM check health results $DISM checkout string hashtag repair component store if needed if $DISM check match component store corruption detected. $dism repair equals dism. /online/ cleanup image /restore health limit access add content. Path $log file. Value DISM repair results. $dism repair out string. Hashtag run SFC $SFC scan equals SFC / scan now hashtag log the SFC results add content. Path $log file. Value SFC scan results. $SFC scan out string. Hashtag send email notification $AP server equals mail.yourdomain.com $from equals it dash alerts at yourdomain.com $to equals junior admin at yourdomain.com $subject equals monthly maintenance report $MV computer name $body equals get content path $log file out string send mail message SMEP server $SMTP server from $from to $is subject $subject body $body body as HTML. Use code with caution. PowerShell. B. Group policy settings. Create a new GPO. I'll name it Windows 11 monthly maintenance. Edit the GPO. Navigate to computer configuration, preferences, control panel settings, scheduled tasks. Create a new scheduled task. Action. Create. Name, monthly maintenance. Description, runs SFC and DISM to check system health. User account, NT authority / system to run with the highest privileges. Run with highest privileges, checked. Configure for Windows Vista or Windows Server 2008 or later. Trigger, on a schedule, e.g., monthly, on the first Monday of each month at 2 a.m. Action, start a program. Program/script, PowerShell.exe. Add arguments. Execution policy bypass. File C:\scripts \monthly maintenance.ps1. Start in C:\scripts. Script storage. Place the monthly maintenance.ps1 script in a network share accessible to all domain computers, e.g., \_DC01 \netlogon \scripts. I'll make sure the share has the proper permissions. Link the GPO. Link the GPO to the appropriate OU containing the Windows 11 computers. 3. Justification. PowerShell. It's readily available on Windows systems and can easily run external commands like SFC and DISM. Scheduled task. This ensures the script runs automatically without user intervention. NT authority / system. Running the task as system ensures it has the necessary permissions. Monthly schedule. A good balance between proactive maintenance and minimizing system load. Central script location. Using a network share makes it easy to update the script if needed. Logging. The script logs the output of each command, providing a record of the maintenance performed and any issues found. Email notification. This will keep me informed about the results of the script, especially if errors are detected. I think this approach automates the process effectively and uses the appropriate tools within our Active Directory environment. What do you think? Are there any improvements I should make? Warning: 39.0s. Simulate the answer as Senior IT. This is an excellent start. You've shown a good understanding of how to combine group policy and PowerShell for automated maintenance. Your script is well structured, and your GPO settings are mostly correct. This demonstrates your grasping how to apply these concepts practically. Feedback on your proposed solution. Strengths: well-structured script. Your PowerShell script is logically organized, with clear steps for checking DISM, repairing if needed, running SFC, and logging the results. Correct use of DISM and SFC. You're using the appropriate commands for checking and repairing the component store and scanning system files. Good use of logging. Logging the results to a file is crucial for monitoring and troubleshooting. Appropriate GPO settings. You've correctly configured the scheduled task within group policy, including setting the user account to nt-authority/system and using a monthly trigger. Email notification. Having an email notification set up will greatly improve visibility into any issues that may arise. Weaknesses and areas for improvement. Error handling. Your script lacks robust error handling. What if DISM or SFC encounters an error? The script should check for errors and log them appropriately. Additionally, the email notification should only be sent if an error is found. Otherwise, you may train yourself to ignore these emails. Hard-coded log file path. The log file path is hard-coded to C:\Windows\temp. This might not be ideal for all systems. It would be better to use an environment variable like %systemroot%\temp or allow the path to be configured via a parameter. Email trigger. You are sending an email every time the script runs. This may be okay, but it may be better to only send an email if an error is found. Script location and permissions. While using the Netlagon share is a possibility, it's generally recommended to use a dedicated share for scripts and software deployment. Also, you need to be more specific about the permissions needed on the share. Authenticated users should have read and execute permissions. Execution policy. You're using execution policy bypass. While this works, it's not the most secure approach. A better practice would be to sign your script with a code signing certificate trusted within your domain. This allows you to set a more restrictive execution policy. Component store cleanup. You are checking the component store health, but not performing a cleanup. Consider adding a cleanup command if it is deemed necessary by the health check. Alternative approaches and best practices. Modular script design. Consider breaking down your script into functions for better organization and reusability. For example, you could have functions like test component store health, repair component store, invoke SFC scan, and send email notification. Advanced logging. Instead of just appending to a text file, consider using PowerShell start transcript and stop transcript complets to create a more detailed log of the script's execution. Centralized logging. Instead of individual log files on each computer, consider logging to a central location, e.g., a network share or a syslog server, for easier monitoring. You could use a try/catch statement to first attempt to log to a network location, and then log locally if that fails. Configuration management. For larger environments, consider using a configuration management tool like PowerShell DSC, desired state configuration, to manage the scheduled task and script deployment instead of relying solely on group policy. Revise script example. Here's an example of how you could improve your script with error handling and some of the suggestions above. Hashtag, configuration section, $log file directory equals $v. System root \temp, $smtp server equals mail.yourdomain.com, $from equals, it-alerts at yourdomain.com, $to equals, junior admin at yourdomain.com, $email on error only equals $true hashtag. Function, test component store health. Function test component store health, perum, $log file, $check equals DISM/online/cleanup image/scan health add content. Path $log file. Value DISM check health results. $DISM checkout string. If $DISM check, match component store. Corruption detected. Write warning component store corruption detected. Return $true, else, write output component store health check passed. Return $false, hashtag, function, repair component store. Function repair component store perum $log file, write output, attempting to repair component store. $and repair equals DISM slash online slash cleanup image slash restore health slash limit access add content. Path $log file. Value DSM repair results. $DSM repair out string. If $last exit code, 0. Write error, DSM repair failed with exit code, $last exit code. Return $false else write output component store repair completed. Return $true hashtag, function, invokes SFC scan. Function invokes system from $log file, write output, running SFC scan. $scan equals SFC slash scan now add content. Path $log file. Value SFC scan results. $SFC scan out string. If $last exit code, 0, write error. SFC scan failed with exit code, $last exit code. Return $false else write output SFC scan completed. Return $true hashtag. Function. Send email notification. Function send email notification perum $subject, $body. Try send mail message. SMEP server, $SMEP server. From $from. To subject, $subject. Body $body, body as HTML. Error action stop write output. Email notification sent successfully. Catch write error failed to send email notification. $, exception, message. Hashtag, main script. Hashtag create the log file path $datetime equals get date. Format YY1 $log file equals join path. Path $log file directory. Child path. Monthly maintenance _$datetime.log. Hashtag start transcript logging start transcript. Path $log file write output. Starting monthly maintenance on $env. Computer name. Hashtag perform component store cleanup $dism cleanup equals DSM slash online slash cleanup image slash start component cleanup add content. Path $log file. Value DSM component store cleanup results. DISM cleanup out string. Hashtag test component store health $component store corrupted equals test component store health. Log file $log file hashtag repair component store if needed if $component store corrupted. $repair result equals repair component store. Log file $log file hashtag run SFC scan $SFC result equals invoke SFC scan. Log file $log file hashtag stop transcript logging stop transcript hashtag hashtag send email notification if errors occurred or if email on error only is false if $component store corrupted and $repair result or $SFC result or $email on error only. $subject equals monthly maintenance report. $MV computer name. Errors found $body equals get content. Path $log file out string send email notification. Subject $subject. Body $body write output. Monthly maintenance script completed. Use code with caution. PowerShell. Further considerations. Testing. Thoroughly test your script in a lab environment before deploying it to production. Code signing. Sign your PowerShell script with a trusted code signing certificate. Documentation. Document your script, including its purpose, parameters, and any dependencies. Version control. Store your script in a version control system like Git to track changes and collaborate with others. By incorporating these improvements and continuing to learn and experiment, you'll become more proficient in using PowerShell and group policy for proactive system maintenance. Keep up the great work. Now, for the next phase, let's move on to a more advanced scenario.
So I see this is a very, very good example, but one thing here I noticed in the answer, which seems to be very, very important concerning one of the things that you have made restore health slash limit access, which is not correct because we need to repair the files using DISM from the internet. And again, there is another problem concerning the script itself. So we create a schedule task to run the PowerShell script. Here it is he is suggesting to put the script in the net login shared folder, but the schedule task itself, we can see that the script is in a folder called C script. So this should be changed to reflect a shared network folder, not local. So this is a script. We need to make sure it is available on a net share, or available on a shared folder. Okay, here is saying that the script, it is in the C scripts, or this is simple. There is a way that you can copy the script to all of the machines, but the simple way is to share the script in a shared folder and tell the schedule task to run this script. Anyway, so this is the one problem I see in this answer. As for the scripting, this need to be tested, because actually I don't know if the script is correct or not, but anyway, seems logic from my point of view, or from my limited knowledge about scripting, but seems to be good. And actually this is another way how we can get the most out of the AI tools. So we can see we have already tell the AI to create exercises uh, to explain the topic, but I think this dialogue seems to be more effective way of learning. We can see that the answer is a little bit simple. There is some tweaking on it, so you can know, or you can see how the answer is evolving, or it is enhanced. We can see that some points are missed, and actually I think this is logical. From if you are acting as a junior IT, you maybe might bypass some of the things that the answer have said. As a senior IT, you can see this is more advanced, more professional. As you can see, we can learn from it, and I think this is a very unique experience of learning. We can learn any topic using different prompts. For example, we can learn using hands-on exercises for a topic, or using a dialogue situation like what we are creating now, or we can just tell him to explain it in simple terms, and it will give us a very short, brief answer. So we can see a lot of ways to learn any topic using different prompts given to the AI tools. So in the upcoming video, with God will, we will continue another scenario, which is scenario 4, and then we will try to ask Claude. And actually Claude is also giving a very good example, and very good scripting method, and actually the answer is very rich. So I am very excited to read the answer of Claude. So until we meet the upcoming video, with God will, hope this video is informative for you all, and thank you all for viewing. Thank you so much.